So in this video we're going to revisit the logistic model, and we're going to develop some code, take some code from, again, based on the HMDA dataset that we've been working with so far. So this is a dataset from Manel et al. 1996, and then subsequently presented and explained in Stock and Watson, that econometric textbook, Introduction to Econometrics. And in addition, there is another book freely available on the internet that we can find at this address. So if we copy and we go into, let's paste and go, I think it's chapter 11 of that textbook, and we have regression with a binary dependent variable. Just to note, the authors here in the preface, so they've done a remarkable job. Christoph Hank, Martin Arnold, Alexander Gerber, and Martin Schmelzer, and they've put together a really terrific resource, and I strongly recommend the book in its entirety. But we're going to focus here on chapter 11, which teases out the treatment of the HMDA dataset, and that was presented in Stock and Watson. Now, the library that's used in Stock and Watson in here is AER, but it's the same dataset. So if we look a little bit at the data that's presented, the HMDA data from AER, it's identical data, deny. This would have been DIR, this is HIR, LVR, CHIS, I think that's the credit score, mortgage credit score, the PBCR, self-employment, DMI. So African American, single, high school. Now, we didn't have that column, so I think that's another column that's there, but otherwise the data is identical, right? So we're working with the same data. So I took the code from this textbook, and then I retooled it or repurposed by reverting back to the headings, the labels in the ECDAT library. And so I follow in, I adopt the code from this textbook, but I use the other labels. I use the labels from the ECDAT, and that the benefit of that is that we then have a set of variables that have consistency. Their naming consistency is in line with the variables that we had used from Halvarian, right? So it's just so that we can directly compare variables and perhaps avoid unnecessary confusion. But we could have also loaded in the same data from the AER library and invoked that. But here we're going to use the data set coming from ECDAT. So first thing I need to do here is copy. I need to make one change here. So we paused and now we resume, and I've just included here the appropriate reference to the library. Again, this is just to be consistent with Halvarian. Let's copy our code then, right? The code coming in from chapter 11 of this textbook here. So there's a hyperlink as well. Might be no harm to show chapter 11, and we'll then go into RStudio Cloud and we'll create a new file, new RScript, and okay, so we're reconnecting to the server, so I'll pause. So again, we need to file, new file, and then RScript, and we can paste in the code we just copied from the portal, and we can give this a name. Let's file, save as, and it's HMDA, and it's introduction to econometrics. So it's chapter 11, introduction to econometrics, using R, and the web reference econometrics metrics using R. Okay, and econometrics. Okay, let's save, and we can now see that appears in the file here. So HMDA chapter 11, introduction to econometrics using R. So okay, that's saved and it's in the cloud. And we can access it through our portal by logging into RStudio Cloud. And again, it's from the textbook, Introduction to Econometrics. And we're now down at library. And let's run that, and not a problem. Library party, we don't actually need that snippet of code because we won't be using C3. Again, the data that we'll bring in is HDMA, names, HDMA, and we should be using the old data set. So we need to be, okay, so a quick copy and paste just to exclude incomplete data variables. Okay, so we're aware that there's one incomplete variable, and we'll make that change as well here. So we'll paste. Okay, so again, following Halvarian's excluding incomplete entries, we'll create a data set all, and if I empty this out and use all, we have the 2380 observations, and with the same data set as before, so that looks fine in the RStudio viewer. Now we want to select the deny, and we change that as a numeric. So we change from a yes or no. We didn't do that before, but we'll do it now, and we'll run our regression where we perform a linear OLS estimation, where we estimate just very simply a univariate regress DIR, the debt expense to income ratio, on whether the mortgage was approved or not. Okay, so let's take a look at that, and we run, and then we can present the findings here, and this is just a simple OLS regression, and we can see that the higher DIR is, the greater the likelihood of the mortgage being rejected, where 1 is yes denied and 0 is no, the mortgage was accepted. So 1 here is the mortgage was denied. Okay, we could have a look again at all, and you might notice here now, because of the change from the numeric, deny 0 means no that the mortgage was accepted, and a 1 would denote that the mortgage was not approved. So the applicant was unsuccessful. And how did we change the yes, no to 0 and yes to 1? We performed that action by taking just converting to a numeric. Okay, so we'd like to now plot. Okay, so we'll set out just briefly a plot of the 1s and the 0s, noting that the 1s here denote that the mortgage was refused, and 0 the mortgage was not denied, so the mortgage was approved. So the 0s denote here the mortgage was approved, the 1s denote that the mortgage was, the applicant failed in getting their mortgage. What we might say here is that as the DIR increases, we tend to find we're more, it's more associated with this higher line here at the 1s, and we might expect that there's a positive relationship between DIR and deny. And of course we've already seen that in the terms of the output here. When we run deny mod 1, which is the linear regression model, we can see a positive relationship between DIR and the mortgage being denied. So yes, deny, no would mean approved. We've plotted out the variables, and okay, once we performed that action, then we want to put in lines, ab lines, and that will connect up the each applicant dot, and then subtext mortgage denied, and then the 0s mortgage approved. Okay, so that we understand. And then the model fit, right? And this is generated from the linear regression model. And one of the features of an OLS linear regression model is that it will breach 1s and 0s. So in theory, when we're predicting a probability, we should be bounded by 1 and bounded by 0. And it's fairly clear to see here that the ordinary linear OLS model, ordinary least squares model, produces output not consistent with the framing of probability. So we start to exceed 1, and we go into a range that is negative, and of course you can't have negative probabilities. Okay, so next then we could make our model more sophisticated, and again the original intention here when investigating the data set was to try and determine was being African American, was that a feature, was there discrimination in terms of the mortgage origination process, and were African Americans more subject to discrimination than other population sample. And let's run that and then get a summary of the model. And what we observe here directly is, yes, the higher DIR, the more likely it is that the mortgage is rejected or mortgage is denied. And also if you're African American, equally, and it's statistically significant, the t-value is quite high, we also note that that is associated with a higher likelihood of the mortgage being denied. So we have prima facie evidence to support our contention that there is discrimination, but of course we have to control for risk factors like LVR or the credit scores and so on. So we need to introduce those. In the next video we'll continue with this analysis, but we'll introduce the Logit model. So we'll run the same estimation, but with the Logit